In this video, we want to invite Bill, Jeff, Mark and Elon to a party. Whether or not this party will take place will depend on the logic of the AND or NAND gates. Invite these guests in 2 guest, 3 guest and 4 guest modes. First, the probability of the presence or absence of each of the guests in the above cases is examined. Programming is then done based on the AND or NAND logic gates to determine whether or not the party will take place. The programming of these logic gates is done in Siemens PLCs and in Step7 software and in 3 languages, LAD, STL and FBD. These programs are offered in 2 guest, 3 guest and 4 guest modes and in 2 different ways for the NAND logic gate. Finally, the Boolean algebra for these logic gates, and the proof of Demorgan's first law, are represented by the 2 NAND gate methods. Stay with us until the end of the video.
Hello, welcome to PLC Channels. Dear Mr. Bill, dear Mr. Jeff, dear Mr. Mark and dear Mr. Elon, I invite you to a party. But before that, I will consider the possibilities of this party. Suppose I just invite Bill. In this case, there are 2 possibilities. Either Bill comes to the party or he doesn't. Suppose I just invite Bill and Jeff. In this case, there are 4 possibilities. One, none of them come to the party. 2, only Bill comes. 3, only Jeff comes. 4, both Bill and Jeff are coming. If I invite 3 guests like Bill, Jeff, and Mark, there will be 8 possibilities. As you can see, in the first possibility, none of the guests come to the party. And in the 8th possibility, all the guests come to the party. Or, for example, in the 5th possibility, only Mark comes to the party. If I invite all 4 esteemed guests, there will be 16 possibilities. At first possibility, none of these guests will come. And in the 16th possibility, all 4 of them will come. Or, for example, in the 13th possibility, only Mark and Elon come to the party, and Bill and Jeff do not. As you can see, as each guest increases, the number of possibilities doubles. Therefore, the number of probabilities is equal to 2 to the power of n. N is the number of guests. Now, again, I look at this issue. Another point about the order in which probabilities are written in the truth table is this. In the first column, a number no and a number yes, alternating. In the second column, 2 number no's and 2 number yeses, alternating. In the third column, 4 number no's and 4 number yeses, alternating. In the fourth column, 8 number no's and 8 number yeses, alternating. This order is due to the correct order of counting on the binary numerical basis. Now we see the possibilities of having a party, which has 2 probabilities. The first possibility is that this party will not be held and the second possibility is that this party will be held. Now, I start programming. First I double-click on the schematic manager icon. I click on New. And in the name box, I write the name of the project. For example, I type, AND. Then right-click on AND. And enter the new object. I click on S7 Program. Then I click Blocks, OB1 and OK. The programming window opens. First, from Options, I click Symbol Table. The Symbol Editor window opens. In the first row, in the symbol column, I type bill, and in the address bar, I type I0.0. In the second column, Jeff and I0.1. In the third column, Mark and I0.2. In the fourth column, Elon and I0.3. In the fifth column, the party and Q0.0. After saving, I return to the Schematic Manager window and click on Simulation. And Logic Gate Programming with 2 guests. For programming the Logic Gate and with 2 guests, I open the Lab Programming window. At in Logic Gate, this party is only held if all the guests are present. Otherwise, this party will not be held. I write the program by serializing 2 normally open contacts and connecting them to a coil. I type the name of the first contact, Bill, and the name of the second contact, Jeff. And I type the name coil, party. After saving, downloading and monitoring, I test the program in simulation. Remember, this party is only held if all the guests are present. You saw the test of this program with 4 available possibilities. Now, see the programming of the AND gate with 3 guests. It suffices to look at another normally open contact, named Mark, after Jeff. I test. You can see that this is exactly the logic of the AND gate. The party is held only if all the guests are present. I did not try all 8 possibilities, and I tested 4 possibilities. Because according to the LAD program, we find that in order for the current to pass from left to right, all 4 contacts representing 4 guests must be connected. For programming the AND gate with 4 inputs, I set up another normally open contact, named Elon, after Mark's contact. I download and test the program. This time there are 16 possibilities, again only in one possibility, this party will be held, and that is the simultaneous presence of 4 guests in this party. I test 5 possibilities. You do not need to test all 16 possibilities. Because in a circuit where there are 4 series switches of normally open type, it is necessary to connect all 4 switches to turn on the lamp. Here, each switch represents one of our guests and the lamp represents the party. Now I do the same thing in STL. First I click on STL from View. And I delete the previous program. I type A, space, Bill, enter, A, space, Jeff, enter, equal, space, party, A stands for and. I'm testing. Since we have 2 guests, there are 4 possibilities. And only in the event that both guests are present, the party will be held. Now I want to add another guest in STL. To do this, in the 3rd line of the previous program, I type the phrase A, space, Mark. I also test this program in simulation. As you can see, out of 8 possibilities, the party is held at that probability, when all the guests come. To add a 4th guest, I type in the 4th line. A, space, Elon. Test, out of 16 possibilities, only the last possibility holds the party. I run the same program in FBD. From View, I click on FBD. I am deleting the previous program. I click on the AND gate and then the output. I type Bill and Jeff's names in the inputs and to the left of the gate. And to the right of the gate, on output, I type the word party. After downloading, I test the program. The result is similar to previous programs. To add mark, click on the AND gate. And I click on bin. Input. Now next to the new entry, I type the name mark. Again, you can see that the party is held only if all the guests are present. To add Elon, I click on the AND gate. And I click on bin. Input. Now next to the new entry, I type the name Elon. Again, you can see that the party will be held only among the 16 possibilities, if all the guests are present. The AND gate check is over. Now I start teaching the NAND gate. At the NAND logic gate, the party is not held only if all the guests are present. In other possibilities, the party is held. The NAND logic gate programming has two methods. Method 1, LAD language, 2 guests. First I connect two normally open contacts and connect them to the output. The AND gate was created. Now, before outputting, I put the NOT command. The NAND gate was created. Then I type the names of Bill and Jeff on the contacts. And on the output, I type the party. I save the program, download and monitor. You can see that out of 4 possibilities, only in one possibility, the party is not held, and that in a situation where all the guests are present. To add a third guest, I click on the left side of the NOT command and add in normally open contact. And I type the name mark on it. I test. Out of 8 cases, in 7 cases, the party is held. And only when everyone is present, the party is not held. To add a fourth guest, I click on the left side of the NOT command and add in normally open contact. And I type the name Elon on it. I test. Out of 16 cases, in 15 cases, the party is held. And only when everyone has come, there is no party. Stupid. But it makes sense. Because it is subject to the NAND logic gate law. I start the first method of the NAND logic gate with the STL language. It reads AND, space, Bill, enter. AND, space, Jeff, enter. Not, enter. Equal, space, party. The NOT command reverses the result. I test. Look carefully at all 4 possibilities. The party is held only if all the guests are present at the same time. To add a mark, just type the phrase before the not command and space mark. I test. Look carefully at all 8 possibilities. The party will not be held only if all the guests are present at the same time. To add Elon, just type the phrase before the not command and space Elon. I test. Look carefully at all 16 possible possibilities. The party will not be held only if all the guests are present at the same time. I start programming. The first method of the NAND logic gate with the FPD language. I first write the end program. Then I add not to the left of the output. I save the program, download, monitor. Again, you see, if all the guests are present at the same time, the party will not take place. To add another guest, I first click on the in gate. Then I click on bin input. And I type the name mark at the entrance to the gate. I test the program. Again, you see, if all the guests are present at the same time, the party will not take place. To add a fourth guest, I first click on the in gate. Then I click on bin input. And I type the name Elon at the entrance to the gate. I test the program. Again, you see, if all the guests are present at the same time, the party will not take place. The training of the first method of non-gate programming is over. I start teaching the second method. I start the programming with 2 guests and in NAND language. I connect 2 normally close contacts in parallel, and I connect them to the output. On these 2 contacts, I type the names of Bill and Jeff. And on the output, I type the party. After saving, downloading and monitoring the program, you will see that the party will not be held only if all the guests are present. It behaves exactly the opposite of the AND gate. That's why it's called the NAND gate. The important thing is not to be deceived by the appearance of this program. Do not think that because it looks like an OR gate, it should be an OR. No, not at all. But because its truth table is exactly like NAND, so is NAND. To add another guest, I add another normally close contact in parallel. And I type the name mark on it. In the simulation, you can see that a party is not held only if all the guests are present. To add the 4th guest, I add another normally close contact in parallel. And I type the name Elon on it. In the simulation, you can see that the party is not held only if all the guests are present. I emphasize again, do not be deceived by the appearance of this program. Do not think that because it looks like an OR gate, it should be an OR. I start programming the second method of the NAND logic gate with the STL language. I type the following expressions. O-N space Bill, enter. O-N space Jeff, enter. Equals, space party. The ON command stands for or, not. After downloading, I test the program. You can see that out of 4 possibilities, only in one possibility, a party is not held, and that in a situation where all the guests are present. To add mark, it is enough to type the phrase in the third line. ON, space. Mark. I test. Look carefully at all 8 possibilities. The party will not be held only if all the guests are present at the same time. To add Elon, it is enough to type the phrase in the fourth line. ON, space. Elon. I test. Look carefully at all 16 possible possibilities. The party will not be held only if all the guests are present at the same time. I start programming the second method of the NAND logic gate with the FBD language. First I click on the OR logic gate. Then I NOT both entries. And I type the names of Bill and Jeff next to the entrances. And on the output, I type the party. I save the program, download, monitor. Again, you see, if all the guests are present at the same time, the party will not take place. To add another guest, I first click on the OR logic gate. Then I click on Bin Input. After noting the new entry, I type the name mark next to it. I test the program. Again, you see, if all the guests are present at the same time, the party will not take place. To add a fourth guest, I first click on the OR gate. Then I click on Bin Input. After noting the new entry, I type the name Elon next to it. I test the program. Again, you see, if all the guests are present at the same time, the party will not take place. The training of the second method of programming the NAND gate is over. Now, instead of the names of these four esteemed guests, I put the letters A, B, C, D. And instead of the party, I put the letter Y. I put 0 instead of no. And 1 instead of yes. The truth table in the AND gate will look like this. In general, we can say that in the AND logic gate, the output is 1 only if all the inputs are 1. In other possibilities, the output is 0. Example, in the AND logic gate, we have 7 inputs. The number of probabilities of the truth table is equal to 2 to the power of 7, or 128. The number of probabilities in which the output value is 0 is equal to 127. The number of probabilities in which the output value is 0 is equal to 1. See the truth table of the NAND logic gate with 4 guests. I will apply the changes I mentioned earlier. This is the general form of the NAND logic gate with 4 inputs. In general, it can be said that in the NAND logic gate, the output is 0 only if all the inputs are 1. In other possibilities, the output is 1. Example, in the NAND logic gate, we have 10 inputs. The number of probabilities in the truth table is 2 to the power of 10 or 1024. The number of probabilities in which the output value is 0 is 1. The number of probabilities in which the output value is equal to 1 is 1023. In Boolean algebra, the formula for the logical gate AND with 2, 3, and 4 inputs is as follows. As you can see, the point, or multiplication, symbol is used to indicate the concept of the AND gate. In Boolean algebra, the formula for the logical gate AND with 2, 3, and 4 inputs is as follows. As you can see, the point, or multiplication, symbol is used to indicate the concept of the AND gate. In Boolean algebra, the formula for the NAND logic gate with 2 inputs and 2 methods is as follows. Because the function and truth table of both methods are the same, then the 2 formulas are the same. And this is the proof of Demorgan's first law. In these formulas, the line on the letters represents not the point sign, or multiplication, to indicate the meaning of the gate AND, or the series of contacts, and the plus sign, or add, indicates that the contacts are parallel. Please click the subscribe button at the bottom of this video and write your comments about this video in the comments section. If you like this video, like it.